Good afternoon, class. In today's video, what I wanted to do is to go over an example problem from electric power, part 2. This one is going to be number 7 in that, this example problem is going to be number 7 in that review set, problem set. So I thought if you wanted to follow along, feel free to do so. So we start off with our power equaling 1 watt. We don't know what our current is, and our resistance is going to be 2 ohms. So we're going to use the equation P equals I squared R, like it says in the example problem, and we're going to just go for it. Plug in we're going to plug in the values into the variable, all our given information, and solve. Now, before I get into all of the math of this, I did want to point out there is a reason that I chose this specific problem and not, like, say, number 2 or number 1, mostly because those are a little bit on the more trivially easy side to handle, especially at your mathematical level. This one, on the other hand, might be a little bit harder, and especially because we're going to get into a little bit of a math topic here that, you know, it's called rationalizing the denominator. It works, you know, but all I'm doing, you know, and you'll see what happens when we get into it. So let us do this. So we're going to plug in our information. Our power is 1, I squared, we don't know, and our resistance is 2 ohms. So I look at this and go, all right, I squared is being multiplied by 2, so to isolate the variable, I must do the opposite operation. And the opposite operation of multiplication is division. So I'm going to divide both sides of the equation by 2. That gives me I squared equals to 1/2. And then now I have to look at this again and say, okay, what's being done over here? Well, I is being squared, so I need to do the opposite operation of the square function in order to isolate my variable I. So the opposite operation of squaring something, or raising it to a certain power, is to take that power's root. You know, so in other words, if I raise I to the nth power, I'd be taking the nth root of it in order to get the answer. So because it's being squared, I'm going to take the square root of both sides of the equation. So I get the square root of 1/2 is my current. Now, you might think, okay, well, square root of 1 is 1, and the square root of 2 is just square root of 2. And, you know, for some of your math teachers, they might say, oh, okay, 1 over square root of 2, that's fine, not a problem. But some of your math teachers will say, you're supposed to make sure that denominator is a whole number and it is not a square root. And I tend to agree with that, only because a square root of this nature is an irrational number, so it'd be like 1.4 something time, you know, and it goes on forever. I don't like that. I don't like decimals in the denominator, so as much as possible, I want it to be gone. So that's why I say what you need to do, and we're going to pull out this is called rationalizing the denominator. This is also called multiplying by 1. So it's a really nice little trick here that I can do to one side of the equation, and it won't affect the other side of the equation because I'm not really doing anything of substance to the equation as a whole. I'm just trying to get some clarity in how I'm going to present this fraction. So 1 over square root of 2, so I'm going to multiply it by 1, which is square root of 2 over square root of 2, like I showed right over here. So now that I've done that, square root of 2 times square root of 2 is square root of 2 squared, which is just 2. And then, so that's nice. We put that in the denominator. 1 times square root of 2 is just square root of 2. So your answer becomes square root of 2 over 2 amps. And so that's how you solve number 7. And, you know, hopefully this one is probably the hardest one of that set. So I'm trying to do this to make sure I give you the hardest problem as an example, so that the other ones are much easier to deal with. So that concludes this example problem. Good luck in your studies. May the force be with you.